Hello, Doko here. What I want to show you today is I have implemented a state, the initialization state of Robotic Enterprise Framework, RE Framework, better known as RE Framework. So I've just basically used the template here and I've created a process here, which is just a RE Framework process. And if I go back, this is the process. And what I've done is I have implemented the initialization stage just to show you what it looks like using coded automation. So if we open the initialization state, we can see that we basically initialize the system exception, and then we go through and we check if it's a first run. If the config is null, then we get the resolution of the screen and we print that out as a log message. We then call initialize all settings, which is under the framework, which will initialize all the settings according to what's in this XAML file. Pass in the three arguments, which are these three. The out config, so basically what initialize all settings will do, it will populate the configuration file, which is a dictionary, and it passes in the name of the configuration file and the sheets, the two sheets, the settings and the constants, and this is what it will look at these two sheets and populate them into a single dictionary, and it will return that as the configuration. Then what we do is we check to see if some settings were made, and then we overwrite. So according to these, if this particular parameter was supplied, then we'll overwrite what was in the config file. So normally you wouldn't be setting things in the config file, but in this case we'll be setting according to this to overwrite. Normally you just read it in and then get the values, but in this case we're doing some setting on the config file. So we're updating here, and if the in orchestrator queue name was supplied as a parameter, then we'll overwrite it in the config file. And same with this one, if the in orchestrator queue folder name was supplied, then we'll overwrite that. So this is just some setup, and this is just for backwards compatibility, as it says in the comments. Then we call kill all processes, which is calling the kill all processes over here. We add a log file field. So this is something to do with our logging, so when the logs are generated. And then we do some checks about the system errors. If it's consecutive system exceptions were exceeded, then we throw an exception based on these particular conditions here. Then we throw an exception, and then we invoke the init all applications, which is over here, part of the framework. Init all applications. Parameter we pass in is the config file, and then if there was an exception down here, catch the exception, and we just basically set the exception to whatever the exception was. So in the next stage, if there was an exception thrown in this initialization stage, a system exception, then basically the framework would terminate and that would be the end of the process. So that's what we're implementing. So there's a little bit of, I just chose this as an example just to show you a little bit of logic, and everything's encapsulated within the try catch. So we're doing all these steps here. So what I've done here is I've already written the code for this in the initialization.cs, which is a workflow, which is a coded automation workflow C# file. So you can see here I've created an nconfig class which contains the dictionary, which is this internal dictionary, DCT, and then the get and set can be done through this DCT with a capital letter. So the reason I've done this has actually been generated by my code, by a utility I've written that will basically look through the config file and create this class for me based on the contents of the config file. So the config file by default, it doesn't, the tool doesn't generate any sets. So these ones where I've had to set, I've added in the set here because we have to set the orchestrator queue name or the orchestrator queue folder if there was an in parameter supplied. So I've just added in these extra sets, so this wasn't generated. The rest of it's all generated based on the contents of the config file. So the type is nconfig and it contains a dictionary. The reason I've got the get and the set here is because I need to either retrieve or pass back the value when I'm calling the XAML files. I need to pass the dictionary, not of type nconfig. I'm just using nconfig so I can use IntelliSense in my code here. So if you write this in C#, you basically, I've put it into sections like this, so it's very easy to read. So the reason it's like this, if you're not aware, is you can just put regions and it allows you to open and close them, so it's a lot easier to read. So I've got a declaration section where I declare my variables. So my variables here, I've just got a dictionary. This is just used for when you're calling the XAML files. I need a dictionary to pass in my parameters. The result, which is of type, which is an interface of type dictionary, and I just have to declare that as a null dictionary to start with, if I want to declare it at the start. System exception, this would probably be in the XAML file. This is like a global because all the states. So this might be a this can be a local, and then you've got the in queue strings. Now these two would be parameters. I've just put them here as variables just to show you, and the consecutive exceptions here would also be a parameter, a global as well. And I've just set the configuration to null. So this is just what I need for the setup. And the first thing we do is we check if the config is null. If the config was null, means that this is the first time we've run it. So if we go back here, we're just basically following the logic here. So this is the if the config was null, then this is the first run, and we start following this through. So mapping onto the logic, the first thing we do is log the screen resolution. So the code to do that would just be using this screen.primaryscreen.bounds. And to do that, you need to include system.windows.form to get access to this screen class here. And that will give you the same message. You just log that. The primary resolution is the width and the height. So that's just a log message. Second is to invoke init all settings. Now that's just calling the XAML file. Now, of course, this init all settings over here in the framework, I could have obviously written that in C# and not call the XAML file, but I'm leaving these existing XAML files and I'm just replacing this code here. So I'm not, obviously I can rewrite those XAMLs, but I'm not rewriting the whole framework. I'm just showing you an example for the initialization part. So basically what we do here is we declare a dictionary, add our parameters, and then run the workflow, pass in the parameters and get the result out. The result will be a dictionary that we're passing back out. So when we init all settings, we're returning the dictionary, and the dictionary will be stored in our variable, which is config.dict. So config is of type nconfig, which we've declared at the top. I showed you in the declarations there. Now the second part is to check whether these parameters had values in them, and if they do, just overwrite the value in the dictionary. So we just check that this has got some non-null value in there, and if it has, we just assign the config value orchestrated queue name. So you can see we're using the dot here rather than the string as we would in the code, because we've got our class that allows us to do that, and we just assign the value. Next section would be for the next variable, the folder name. We check if it was supplied and it was non-null. If it was non-null or not empty, we then assign it over to the folder name in the dictionary. Then we kill all the processes. So again, this is just following what's in the steps here. So we're down to the kill processes here, where we just call the kill processes. Again, we could write this we could write the kill in C#, but I'm just invoking the kill processes. So I just assign a blank dictionary, and then I will just kill the processes. So that will just call and pass in basically no parameters, but we still need to pass in an empty dictionary even though it's empty. So I'm just using the same dictionary that I defined at the top for all of these. Next thing is add the log fields. Now the log fields, I can't write the log fields I don't know how to do this in C#. I didn't see any method at the moment to add a log field in the system settings for the UiPath. So I'm just calling a workflow, which I've created just to do this add log field. So if we come over here, and I've just created a folder here, and I've just created a single add log fields, and what that will do is just call the add log fields as part of some XAML that's here, and inside there, whatever you had in here, we'll just add them into the log fields. So this is just the code basically out of the existing framework. I've just called that single element to allow me to add the log fields, because I can't do an add log fields in the C# at the moment. So that just highlights, if you can't find something in how to do it in C# at the moment, you can just call the existing equivalent in a XAML, just put it in a separate XAML. So that covers if it was null, so that's the if part. And then at the end of that, we check the maximum exceptions, consecutive exceptions, and according to these rules, if if this was greater than 0 and we'd already completed, I think it's 3, then we're going to throw an exception. We've failed 3 times, so then we throw the exception, and that means it will fail. If that didn't happen, if it didn't throw the exception, then basically we initialize all the apps, calling init all apps. So calling init all apps is just passing in the config file, which is config.dict. That will just pass in the dictionary in the config file, and then we run the workflow init all applications. And then the last thing we do is, if anything happened, we need to basically set the system exception to be the exception. So if this was set, if this system exception was set, it means the initialization failed, and we would basically end the process. That's according to the RE framework. So that just gives you an idea of what it would look like to write this if you're using C# rather than writing it using the existing framework as a sequence. So you can see it's the sequence. I mean, this is not overly complicated, but if you're not used to the framework, trying to figure out what's going on here, it's a bit harder to read if you're new to this compared to reading this. You can see it's a lot clearer, a lot simpler to look at this bit of code than to look at the sequence. So I'm just highlighting that. Now the other thing I want to show you is the generation of the class here, the nconfig. I showed you this in an earlier video. I've got a tool to do this that just basically goes through the config file and generates this. So I'll show you that now. So I'll come over here and I'll click on this, and that will run the tool, and then that will generate the file for me. So this has a pop-up, and it tells you that the config file must be in this format: name, value, and description. So you just click OK on that, and then it will prompt you for a config file. So we'll just select the config file, which is the config file from the framework. So once that's run, it will just pop up with the result in a notepad, and you can see what it's done. It's declared these as different classes, settings, and constants, and with 2 different dictionaries. So in this case, you just want to combine this into one class, because that's how the RE framework works. So you just delete one of these dictionaries and then combine these into a single class, and then copy all that over and paste it in, and that's your nconfig, and then you just define this. The other thing I mentioned is these two, the Q name and the Q folder. All I've got here is getting the values. Normally you wouldn't be setting them, so I've just added in 2 extra sets in the code. If we go back over to the code over here, we can see that. So we're back over into the code, and you can see I've got the 2 sets for these two, because we're going to overwrite these, so we just add this in. And we've combined this into a single class called nconfig, and then in our declarations, we've declared how a config in the C# as an nconfig, not as a dictionary. So then we've got access to all the IntelliSense on all these fields in our code. So that just gives you an idea of how we can code our RE framework using C#. I mean, of course, we could convert basically the entire thing into C#. I'm sure somebody will do that in the future, but I'm just showing you as an example here of converting one section of it from our XAML code into our C# code, just to give you an idea of how it would look. And using these regions are quite handy, so you can hide the code, you can hide the comments, so that you can just expand to see what's appropriate, and you can easily read this. It's a lot easier to read and follow the flow, especially if you had a lot of nested conditions here, than it is using the XAML file. Alright, well, thanks very much, and I will talk to you on my next video. Farewell.